Hi everyone. It's been a while since I've done a video. You're probably wondering why. That's because I've been making a lot of things, actually, for leaves. I have a guy who's been wanting stamps and molds for silver casting, so I've been doing a lot of work for him lately and just haven't had the time to get any videos out. But in the process of doing all that work, I've discovered that I really need an automatic tool height setter. Little work like this is impossible to try to switch tools and then use feeler gauges to find the right Z heights. So why don't you come along with me while we make this little guy, a little white box, a tool setting apparatus. I start with a small piece of copper to create the conductive touch plate surface. Why copper? Because I like copper and I've had this piece lying around for ages. There's not quite enough torque on these high RPM spindles at low speed, which is a lesson I have yet to learn. Lighter passes work out just fine though. Despite being able to see the machining marks, it's remarkably smooth to the touch. There was significant chatter on the right side of the part where it wasn't bolted down, but it worked out just fine. It still made excellent chips though. A nice chamfer will finish out the touch plate for now. Now to get started on the body. It's made out of HDPE. This end mill was a poor choice, but it's the only one I had that was appropriately sized for the work I needed to do. It still turned out very nice though. Was I supposed to trim the end of that block? A 1/4-inch end mill will finish up the pocket for the copper piece milled earlier. I don't want it to be a press fit, so I'm sneaking up on the final fit in the pocket. Now just some counterboard bolt holes. This stuff sure does make a mess. Now to manually trim off what I should have trimmed before. And add some holes for the light sensors and wiring. Now I can install it on the table. The last step for the copper plate is to create a tapped hole to connect the wiring. Turns out the fit was still a bit snug if I ever wanted to get the plate out again, but a quick pass with a wider contour operation solved that easily enough. Now to add the cool part, the beam brake sensors. I do need some tiny wrenches. To wire up the fiber optic cables to the control unit, you just stick them in the holes and lock them down. Now to steal some power for the unit. These sensors work by passing an LED light through the fiber and across the air into the receiver and back down the other fiber. It measures the amount of light that makes it back, which can easily be adjusted to trigger exactly how you want it. The red number is the amount of light it's receiving, and the green is at what amount of light you'd like the sensor to trip. I just need to hook that up to another opto isolator and to the probe input on the CNC control board. A quick finger test shows it's working beautifully, as well as triggering the opto-isolator, despite having the trigger value set way too low. A bit of macro programming later, and I have code that will move the tool into the sensor path at high speed, back off some, and then move over to the touch plate and probe at slow speed to get an accurate height value. As a demonstration, I'll set my tool to the top of the vice jaw, zero the Z-axis of the DRO, and hit the P1 button. That will run the first macro, which sets the initial height by storing the height at which the plate is triggered into the C-axis of the DRO. Now I can change the tool and hit the second macro button. This does the same routine, but this time it sets the Z-axis DRO to the value stored in the C-axis once the tool makes contact with the plate. So now the moment of truth. Wrap it back to Z0. And that's all there is to it, for now. I hope you enjoyed the video, and for those of you who may want to make one of these, I hope it's given you some inspiration. Thanks to all the patrons on Patreon for their support, which has gotten us some acoustic panels to make voice recording easier and sound better. If you guys want to toss in a buck or two to help make these videos better, you can head over to Patreon and check it out. Subscribe for more videos like this, and I'll see you guys next time.